So, besides intensive and extensive, we're going to be looking at mixtures, compounds, elements, solutions, molecules. We need to know the difference. So, classifying matter. Do y'all know the difference between an element, a compound, and a mixture?
An element is a like
An element is one, and
compounds are like a mixture of the two, and then compounds are like elements added together, and then mixtures are like.
Yeah.
So
before I even do start the PowerPoint, let me just write some things. So, an element is anything on the periodic table.
No, not Miss Hilton, Miss Fountain. Yeah.
So, for example, iron. It's on the periodic table. It's listed under the Latin name or abbreviation, Fe.
It looks like the tip of it had a quill tip on it.
Yeah, it's a fountain pen.
It's a fountain pen.
It's a fountain pen.
Basically, there's a little tiny slit, and due to capillary action, the ink is drawn down that little tiny slit.
No.
Sick.
So carbon, like our pencil lead, it's on the periodic table.
I thought it was graphite.
Graphite is the name of it. The technical name, it is carbon. Carbon can be arranged in so many different ways. Like, for example, if you crystallize it, it turns into diamond.
So if we do, I'll put liquid nitrogen on it.
No, it takes high pressure.
Are we gonna ever be able to get liquid nitrogen?
Mm-mm.
We totally should.
It's too dangerous.
Put it on my hands.
All right. A molecule. So another name for an element is, you can refer to it as an atom, a single atom. A molecule is when more than one element or atom chemically bonds together.
Wait, are these notes?
Yes.
No, he's writing down for nothing.
Hey, Daniel, are you writing them?
A compound
Just draw.
is when more than one, let me rewrite this. A compound is when at least two different elements bond together, chemically bond together.
So humans are a compound?
We have compounds in us.
What's the big ball of elements?
Oh.
So what fat is when we've got more elements in us?
I have a question, Mr. Wood.
Yes.
Yeah. How does I feel like doesn't a nuclear bomb have something to do with like atoms splitting or something?
Yes, it's whenever the nucleus breaks apart.
Sick.
So, for example, water is H2O. It is an oxygen and two hydrogen bonded together. This is a molecule and a compound. It's a compound because it has hydrogen and oxygen. It has two different elements bonded. Oxygen, molecular oxygen, is O2. It is an oxygen bonded to an oxygen. This is a molecule. But not a compound. It is not a compound because the only type of element is oxygen. It is not a compound because there's only one type of element. It's a molecule because the two oxygen atoms are bonded together. So here's a good quote. All compounds are molecules, but not all molecules are compounds. Molecule just means you have more than one thing bonded together. Compound means you have at least two different things bonded together. Molecule is more generic than it is than a compound. Compound means that you have different types of atoms. Everyone good?
Nah. Right now, I would consider it though. Video is commentary, something like that.
Daniel had a great idea. It's awesome.
Since I'm already doing this, I'll just write these definitions too. A mixture is when two substances are mixed together without them chemically bonding together. So, for example, trail mix. You take some trail mix and put it all in a bag. You can see individual portions of it. They don't just instantly relax. They stay unique. A pure substance is a substance where all the components are made from exactly one type of molecule, compound, element. For example, if you have a glass of water, let's say a glass of pure water, every single molecule in it is H2O. If we have, so this would be a pure substance.
Okay.
If it was pure.
So I have like a experience. Back whenever the dinosaurs were alive, the reason why the caveman survived longer than the natural human is because the water was pure, so was the air.
It's not pure. Salt water is a mixture.
How do you get pure water?
By removing everything, it's very difficult. Salt water is a mixture because it has in it salt, which is NaCl, and H2O. The salt and the water aren't chemically bonded together, so it's a mixture. And it's not a pure substance. It's not a pure substance. Because there's two different molecules, or two different compounds. Because there's more than one compound in it. And mixtures can be broken up, which I'll do here in a little bit.
Wait, like lab time?
No, on the PowerPoint.
Oh. I thought we can go to the lab.
Like, will we ever go to the lab?
Mm-hmm.
Oh, somebody. See now.
Chemistry has a lot more experiments we can do.
Just
The physics portion of this is very difficult. Can y'all are struggling to do the math? How can we go into the lab and have you calculate the math before we do the experiment?
I don't struggle with that. That's not bad.
That's what labs are meant for, is to calculate and make predictions
But also,
and then test it out.
and they make it also try experiments and all that. I mean, you have to calculate it. But
You're supposed to be able, like, for example, how long will it take a ball rolling at 5 meters per second to reach one side of the room to the other?
depends how long when the room is.
Or calculate the speed.
Can I go to the I need to know it. Oh, Mr. West.
Be quick. Did y'all know pure water doesn't conduct electricity?
It doesn't?
Nope.
Like, what number?
Pure water doesn't conduct electricity.
So,
But if there's the tiniest amount of salt or material into it or dirt, it can conduct electricity. And keep your mask on.
Where can we find pure water?
You have to make it.
How do you make pure water?
You can boil the water and collect it, but it takes a tremendous amount of time, and you have to be very careful as some material can get into it.
I'm gonna do it.
I'll be taking toasting bath and
You shouldn't drink it.
I'm not
Drinking
gonna drink it.
drinking pure water is dangerous.
It's gonna kill
Why are
me.
you dangerous?
If you've had biology, there's something called osmosis. So I'll explain that to you. Have y'all had biology yet?
No, I don't have biology this year.
So your cell is filled with a fluid. That fluid is some salt mixed with water. If you put this in a container of pure water, osmosis tells us that the salt concentration is going to want to equalize. So this is way more salty inside your cell. So all the pure water is going to rush into your cell, causing it to swell up and explode.
Oh,
So,
so could we die?
Yes.
so
Your cells are exploding.
I'm gonna
And
try.
You're saying all water pretty much has some kind of salt.
I'm gonna get my dog a drink.
most, yeah, unless you make it yourself. Because there's groundwater, tap, everything.
I'm gonna make pure water.
Imagine killing yourself by drinking water.
Imagine they call it.
Alright. Pure substances. A sample of matter that has a definite, means a fixed chemical and physical properties. Elements, atoms, molecules, and compounds are examples of pure substances. They have fixed properties or definite properties. They have definite chemical properties and definite physical properties. So if you just had H2O, nothing else, it's transparent. It freezes at 100 degree, or at 0 degrees Celsius, 100 and boils at 100 degrees Celsius. Yeah.
Oh, wait, we're allowed to take.
Actually, no. Put your phone up. You're not supposed to have your phone up.
I'll take a picture.
I'm putting this on Google Classroom. Yeah.
This is too late. Apart from home. Oh, too late. Okay.
Elements are pure substances that cannot be separated into simpler substances by physical and chemical means. So these are the things on the periodic table. Water is not an element. It has 2 hydrogen atoms and 1 oxygen. You can break those apart. So elements are pure substances that cannot be separated into simpler means.
So, what's a lanthanide and the actinide?
It's just a series of atoms that are very heavy. Most of them are radioactive. Compounds are pure substances composed of 2 or more different elements joined by chemical bonds. Made up of elements in a specific ratio that's always the same. So every molecule or compound of water is 2 hydrogen for every 1 oxygen. So what it means by a specific ratio. For every oxygen, there's 2 hydrogen. It has a chemical formula. H2O is water. Sodium chloride, NaCl, is table salt. Carbon dioxide is CO2.
So, for every oxygen, you just multiply by 2 to get the hydrogen.
For every oxygen, there's 2 hydrogen bonded to it. Compounds can only be separated by chemical means. You cannot physically separate hydrogen and oxygen. You have to do chemistry in order to break that chemical bond. So tap water is a mixture, and you can turn it into pure water, distilled water. Mixtures are a combination of 2 or more pure substances that are not chemically combined. The substance is held together by physical forces only, not chemical. No chemical change takes place, so they both maintain their individual properties. Each item retains its properties in the mixture. You can also separate it physically. So, for example, to test whether or not salt water is a pure substance, or a mixture, can you separate it physically? Yes, you can by boiling it. You can boil the water, which will separate the water from the things dissolved in it.
Can you boil pure water?
Yes. That's how you make pure water, is by boiling it.
How long is the for?
Until it's all boiled?
Pure water.
So, the difference between mixtures and compounds. Composition of a mixture is variable composition. You can vary the amount of each substance in the mixture. The composition of a compound is definite, meaning you cannot vary the amount of each element in the compound. There will always be a 2-to-1 ratio of hydrogen versus oxygen in water. You can't change the amount of hydrogen or oxygen in water. But if it's a mixture, you can change the amount of the composition. Joined or not joined. The different substances are not chemically joined together in a mixture. In a compound, they are chemically joined together. In a mixture, the properties of each substance in the mixture keeps its own individual properties. In a compound, the properties are different from the individual elements. Water, so oxygen you can breathe. Water you cannot. The properties of oxygen is different than properties of water. Water has different properties than hydrogen and oxygen because they're chemically bond. You can separate easily the substances in a mixture. Usually, yes. Yes, and keep your mask on. It is only able to be separated in it by its elements using chemical reactions for a compound. Examples of a mixture is air. We are breathing a mixture of different gases right now.
Sick farts.
Seawater. Most rocks are actually different mixtures.
Really?
Yes, they're not pure.
That's cute.
Examples of compounds are water, carbon dioxide, magnesium oxide, sodium chloride.
So how do you make bronze?
By mixing together two metals.
Yeah.
Ain't it
Yeah.
like iron?
You paint the color brown.
Ain't it like iron and carbon or something like that?
I think it's copper and
Nickel.
something.
Concrete. You know they make concrete.
So, can you identify the following? You will be shown a series of photos and tell if each one represents an element, compound, or mixture. Remember, an element contains just one type of atom. A compound contains two or more different atoms joined together. And a mixture contains two or more different substances that are only physically joined together, not chemically. A mixture can contain both elements and compounds. Rocks. Is that an element, compound, or mixture?
It's element.
Is it a compound?
Mixture.
So remember, compounds all have the same property. So when something is chemically bonded together, they all have the same property, such as color. If you can see a difference in color on a rock, that means they are not one compound.
So it's a mixture.
It's a mixture of different types of metals and materials. If it was pure, if it was an element or compound, then they would all individually have the exact same properties,
I'm here like that.
which means they'll all be one color. Copper.
Element.
It's an element on the periodic table. Jelly beans.
Mixture. Mixture.
Mixture.
Let's go bacon.
So these have dyes on them, and each dye has to be different than the other ones. Now, if they were well, first of all, we have dye that changes the color. We have sugar in it. Sugar is going to be different than the dye, so that tells you there's two different things. Table sugar. This is a compound.
Oh, what's in that?
It is 12 carbon, 22 hydrogen, and 11 oxygen. It's a very big compound. Diamond.
It's an element.
It's an element. It's pure carbon.
Alcohol wax. 70% alcohol.
Tea.
Mix.
No compound.
No, but there's not different colors. Never mind. Well, there's green tea.
But
But green tea's not green.
you mix
Yes,
like
it is.
What is tea?
It's a mixture.
It's a plant.
Plus, it's
It's
not
a mixture. It's mostly water with a little bit of tea extract in it, and some caffeine. You can boil the water away and be left with only the flavor left.
Sick.
Salt.
It's an element.
Element.
No, compound. That is what compound.
There you go. Compound. It's not on the periodic table. Neon gas.
It's element.
Element. Ne. Solid.
It's a mixture.
That's a mixture.
Definitely a mixture.
I'll laugh at something.
Pure water.
Compound.
Aluminum.
Element. What depends on what kind of aluminum? It's Coke can, and so it's got the plastic. I'd say.
It just means aluminum is not real. It's just showing you an example.
So,
Lemonade.
that
Mixture. Usually you put sugar and other things in it.
and
also water.
Yeah. What about sugar-free lemonade, man?
Silver.
Element. It's 4 hours. AG. Ag.
That's the abbreviation in Latin. Sand.
It's a compound.
So most sand is going to be a mixture. You can end up with a pure sand. Keep your mask on.
Oh, I got the
carbon-free mask on right here.
Don't back talk. We're trying to have a good day today. You come and feel. Dude, you know what? I can have a good day when I'm a field. You know.
I mean, I like this class every day when I come in here now.
Chemistry.
You don't have to, just act like it.
I swear, I love chemistry.
Chemistry is easier than.
I mean, help you learn math. The more you know.
With a Clorox wipe,
Yes.
that's a good idea.
Well,
Want to blow off
I guess I'm dropping on that. Get that burn.
So let's look at the difference between mixture solutions and pure substances.
If we have a little time at the end of class, can we look at more of the like brain?
Illusions.
Did you know that there was
I don't think we will.
a brick made out of tea?
So there are two types of mixtures: homogeneous and heterogeneous.
It's gay.
Homo
And
sapien.
it's better than
You're Homo sapien.
environment.
Homo just means same. Hetero means different.
Heterosexual. Whoa.
Wait, wait a minute, hold on. Well, why do they refer to them as heterosexual?
Because you got
Homosexual,
And then,
it means same sex.
Because you're heterosexual.
Heterosexual means different sexes.
For the longest
Okay.
time, I thought hetero means same.
Homo means same.
So you thought you were.
Genius means type or classification.
I'm straight.
So homogeneous systems mean they have the same properties and compositions in all the different parts. Heterogeneous means different parts with different properties can be found in them.
Can I go there? Should I-
Yes.
Can I go with you?
So here's some examples of homogeneous systems.
Gold, silver, water.
Can you see the differences between the individual parts?
No.
Okay, yeah.
They all look the same.
Yes, okay, so the gold is golden. Okay, so the homo.
Heterogeneuses have different parts. They have different properties.
Okay, can I explain? Open me.
I can sit down for that.
See?
So, for example, blood, there's cells versus plasma. Your blood is sitting in plasma.
Dude, we got
Smoke versus normal air. You can see a clear difference between the air and the smoke. Oil and water. You can see the difference between the oil and the water. Granite. Yes.
Is that red blood cells?
Yes.
I thought it was black cells.
I mean, that's basically our life.
If you were paying attention and listening, I just said what it was. Granite, you can see the individual types of materials are separated. You can see different spots and colors.
Granite tabletops are sexy.
So a heterogeneous mixture is systems with several different substances that can be distinguished. Oil and water. Yes.
So plasma is all blood.
Plasma is the liquid that your blood cells are in.
Is it that white?
Do you
stuff
think
leaks out?
blood is dry?
Is it that white, that clear white stuff that leaks out?
No.
What is that?
That's white blood cells.
Oh,
That's the stuff.
makes sense.
So basically, like first part enough right here where I got the splinter.
Alright. Granite is a type of rock that has 3 different components: quartz, mica, and feldspar. Blood. Using a microscope, we can see a liquid, plasma, and different kinds of cells. And smoke has solid particles in the gas. The gas is air, while usually that's like carbon or some form of ash that's really flying up. You can separate heterogeneous mixtures. One such way is by using a filter. So if you want to separate water and sand, you can use a coffee filter or paper filter, and it'll stop the sand from going through, but the water can get through the pores.
So I'm gonna have to follow.
Do y'all remember what I said? What happens when you have like a how do you separate oil and water?
With a syringe.
You can just pour off the oil. What do y'all remember what I said that was called? And keep your mask on, Cody.
Separation.
Decantation.
Nah.
So this method uses the different densities of the compounds to separate them, such as oil and water.
That's no bacon.
This is just simply pouring off, though usually in science we use this fancy setup where you have a flask and we drain it through a narrow tube at the bottom.
So this is white blood cell right here? I got 3 liquid.
And plasma and water.
Shit. I could have lost, man.
Which means if you pop it and let all the white blood cells out, you're meaning that they're no longer fighting the bacteria in your wound. Which means it could get infected, you could get staph.
Dude, I'm gonna do that next time.
Could get cool.
And
You shouldn't pop.
I mean, I didn't pop it. You should
I'm
not
gonna just sit there and stick that shit on.
So, homogeneous systems. There are 2 types of homogeneous systems: pure substances and solutions. A solution is just another name for a homogeneous mixture. Pure substance, they only have one compound or element, and they have constant composition and properties. Solutions have several components, and their composition can change, such as milk or salt water. A solution has at least 2 compounds. The solute, which is the compound that is present in lower quantity. It's what you're dissolving in it. So salt water, salt would be the solute. The thing doing the dissolving would be the water or the solvent. It is a compound that is in excess. Its states never change when the solution is being formed. So a simple example is salty water. There is much more water than salt. So salt is the solute and water is the solvent.
No need to be smart.
Note, solutions are not always liquids. You can still separate solutions. One example is evaporization or crystallization. So a liquid evaporates at room temperature, but a solid does not.
I have a question.
Yes.
We make aerogel.
No, that requires a very advanced lab.
Wait. Well, milk aerogel is 99%. I have a quick question.
One way you can do this is distillation. It's where you boil one liquid.
I'm gonna do that.
Maybe. So liquids whose boiling points are different. So this is how you can separate salt water too. You can use distillation. This is a real distillation setup. See on the left, you're boiling the liquid. You have a condensation tube, which usually has ice or some cool air running around it.
So basically, moonshots.
Yes, that's what moonshine distillation.
More than that.
Pure substances have constant composition. They cannot be separated in simpler substances using physical means. There are 2 different kinds of pure substances: chemical compounds and elements. Chemical compounds are pure substances that cannot be separated using chemical methods. And This is wrong. Chemical compounds are pure substances that can be separated using only chemical methods. Or I should say cannot be separated using physical methods. That's an error in this PowerPoint. Elements are pure substances that can't be separated into others. Yeah, so Monday I'm going to do a little review and kind of like I did yesterday. We'll review, go back over the differences, then I'll do another quiz.
Okay.
A quiz over what we've done today, or?
Like we did yesterday and the day before.
Oh.
I did PowerPoint and then I reviewed and then... Any questions? Mhm.